Welcome to Physics 101. My name is Dr. Egbert, and today we're going to learn about impulse.
Hey, bro.
Look who decided to show up. So to start, can anyone tell me what an impulse is?
Impulse, like Donald Trump, is very impulsive.
Not quite. What about you, Osama?
Impulse is categorized as a change in momentum within a system due to an average force applied for a period of time. The equation is force delta time is equal to mass delta velocity for a system.
Excellent. So impulse is a change in momentum, which is equal to mass times delta velocity, and is also equal to the average force applied for a period of time. So I'm going to show you how impulse works through a demonstration. What we're going to do is take eggs and drop them from a height of 30 centimeters. The difference is that one is going to be dropped on a hard surface, while the other is going to be dropped on a sponge that is 3.5 centimeters above the ground. What do you guys think will happen when the egg is dropped on the hard surface? Bo?
So the egg will break because the floor is hard.
That is not the answer I'm looking for, but it's partially correct. What about you, Osama?
So, on a hard floor, the egg breaks because a large net force is being applied on the egg for a short time interval by the floor, leading to a high impulse causing it to crack.
Good job, Osama. That is entirely correct. Exactly. As you saw, when we dropped the egg from a height of 0.3 meters, the egg unfortunately broke. Velocity initially was 0 meters per second. The final velocity was 2.42 meters per second. This was gotten from kinematic equations, which we discussed in a previous module. And the mass was 0.058 kilograms, which was obtained from the carton label. When we put this in, we see that a change in momentum is equal to mass times delta velocity, which is equal to 0.14036 kilograms times meters per second. The impulse, therefore, is equal to the average force times delta t, which is equal to 1.4036 newtons of force that is exerted by the ground onto the egg. Extravagant. Now we will see what happens when we take Tuxedo Man over here and drop him from a 0.3 meter height to a bottom that is filled with sponges. So what do you guys think will happen when we drop the egg on a sponge? What will happen to impulse? Bo?
Impulse decreases.
That is not entirely correct, Bo. That is a rookie mistake. What about you, Sama?
So, the impulse doesn't change, but instead stays the same because the force net applied on the egg decreased, but the contact time interval increased, which compensated for the impulse.
As we see, Tuxedo Man is fine and healthy. So, in the experiment, Tuxedo Man survived. So what does impulse have to do with this? Recall, impulse is categorized by force times delta t, which in both scenarios gives us the same impulse exerted. How is that? Well, this is due to the fact that the egg dropped from sponges effectively increases the contact time from a value of 0.1 seconds to one of 0.4 seconds, and decreases the average force exerted from 1.4036 newtons to 0.3506 newtons. Right there. And due to the fact that impulse must be constant. So in conclusion, by having a lower average force exerted by falling on the sponges, the egg effectively survives. This concludes our lesson on impulse. That's all, yolks. Hey, Bo, show some respect.